What we're going to do today is take a look at graphing piecewise functions. And a piecewise function is just a function that uses different formulas for different parts of its domain. And if we look at a triathlon athlete, we're going to swim, bike, and then run. We typically do swimming because we don't want to drown. When you do your swimming event, the time it takes you to swim, you're not going to cover that much distance because it'll be the slowest of the three events. When you start biking, though, you will start to cover a lot of distance because it should be the fastest of the two. Running should be somewhere in between, so it's going to have a slope of somewhere in between biking and swimming. So let's look at the function. We have f of x is equal to x plus 1 when my x values are less than 2, and negative 4x plus 4 when my x values are greater than or equal to 2. What I would suggest doing is drawing a dotted line at x is equal to 2. This is going to be the cutoff point or the restrictions for each function. All right, so I've drawn this cutoff point, and that just shows me that my one function is going to be to the left of this line, this dotted line, and my other function is going to be to the right of that. Here I want the x values less than 2, so this function, x plus 1, is going to be on the left side of this dotted line here. So if I was to graph this, my y-intercept is 1, put a dot at 1, and the slope is a positive 1 over 1. Alright, and just keep in mind, I want the x values less than 2, so I'm going to represent that by an open circle when I get to this orange line. So I'm going to go up 1 over 1, up 1 over 1. This is going to be my open circle. Alright, and then we're just going to draw a line through these dots. The second part of this function, we have negative 4x plus 4. My x values are greater than or equal to 2. Greater than or equal to means that I'm going to use a filled in circle when I'm on this orange line. So let's graph negative 4x plus 4. If I went up to 4 and put a dot, then I went down 4 and over 1, down 4 and over 1, and down 4 and over 1. I only want the piece of this to the right side. The value is greater than or equal to 2, so I only want this part of the function. Alright, remember we're going to use a closed-in circle, so what you could do is go ahead and erase these other red dots that we made. We don't need those. You can also get rid of this dotted line, and that is your piecewise function. Alright, so let's take a look at one more example. The restrictions or the cutoff points are going to be negative 1. So what I did is I drew a dotted line at negative 1, and this function, 2x plus 3, is only when the x values are less than negative 1. So on this line, it's going to be an open circle, and I only want to graph to the left side of that. Alright, so if I plotted 3 on the y-axis, my slope is a positive 2 over 1. That'd mean up 2 and to the right 1. That's not going to be any good because I want to be on the left side of this line, so I want to go down 2 and to the left 1. Keep in mind, that's going to be my open circle. Down 2 and to the left 1. Alright, and we'll draw a line through these points starting at the circle. Alright. The second function, I want the x values greater than or equal to negative 1, so it's going to be a closed circle on this orange line. And I'm going to go down 2. My slope is a 1/2, so I'm going to go up 1 over 2, up 1 over 2, up 1 over 2, and that's the same thing as going down 1/2 and over 1, right there. Alright, I'm going to draw a line through those. I'm going to erase this pink line and also get rid of this orange line, and then we're done.